right, hi everyone. This is our last chapter, chapter 19 on the hypersensitivity reactions. Um, so normally your immune system would protect you, but these immune reactions are damaging and can even be life-threatening. We'll talk about the hypersensitivity reactions. There are 4 different types. And then we'll also talk about some autoimmune disorders. So these are responses to antigens which are allergens, and they can lead to these hypersensitivity reactions. Usually the first exposure is a sensitization exposure, and then the second exposure is when your immune system reacts in a damaging way, which is not protective, and can even be life-threatening. So we'll go through these 4 types of reactions. Type 1 are the anaphylactic reactions. Type 2 are the cytotoxic reactions. Type 3 are the immune complex reactions, and type 4 are the delayed cell-mediated reactions. Okay, so with the immunity that we talked about in chapter 17, your acquired immunity, your first exposure would elicit an immune response which would protect you. For these reactions, your first exposure sensitizes you to the allergen, and then the second exposure is where your immune system reacts in a way that is not protective, that is damaging. Okay, so hypersensitivity is an immune reaction which is beyond what is normal, and that is what leads to the damage. So these are the 4 different types that we mentioned, and the time after exposure when you have clinical symptoms. So the type 1 anaphylactic reactions can occur between 2 to 30 minutes after exposure. The cytotoxic reactions occur between 5 to 12 hours after exposure, and the type 3 reactions occur between 3 to 8 hours after exposure. And the type 4 reactions, because they are cell-mediated, they take a little bit longer, anywhere from 24 to, I believe, 72 hours after exposure. Okay, so we're going to start by talking about the type 1 anaphylactic reactions, and these are, they can be systemic reactions or they can be localized reactions. What happens is you have IgE, okay, which we mentioned when we were talking about the different antibody types, attached to receptors on mast cells and basophils. And when you have bridging, we'll see a figure in a minute, but when you see bridging between 2 of these IgE antibodies by binding to an antigen between the 2 of them, that causes degranulation of these mediators, these vesicles of mediators inside of those cells, and they release they release these mediators, one of which is histamine, okay, which you're familiar with from inflammation. So they can release histamine, of course, which can cause the increase in permeability of the capillaries. They can also release leukotrienes, okay, which cause the contraction of smooth muscle, and prostaglandins, which can increase mucus production. Okay, so if we were talking about a a localized anaphylactic reaction, which would be like hay fever or asthma or hives, something like that, you could see where, these mediators, the histamine, the leukotrienes, and the prostaglandins, could result in edema, redness, runny nose, smooth muscle contraction could cause breathing difficulties, and we'll talk more about that with respect to the systemic anaphylactic reactions as well. Okay, so here we see the mast cell or the basophil, which has all of these granules which contain the mediators. And you can see the IgE antibodies on the surface. And when those IgE antibodies bind to antigen, one antigen between two antibodies, so that you get this bridging effect, that causes the release of the mediators from the granules. Okay, and then those mediators can be, like we said, the histamine or the leukotrienes or the prostaglandins. Okay, and then this is actually a scanning electron micrograph of a degranulated mast cell. So the mast cell has released its granules of histamine, and this is what they actually look like when you're doing a scanning electron micrograph. Okay, so I mentioned localized anaphylaxis, with respect to the mediators, right? That you could have like a runny nose and redness and edema from release of the mediators. Systemic anaphylaxis is a little bit more serious, in that if you have difficulty breathing, if your blood vessels are dilated, that could lead to a dangerous drop in blood pressure, which could even result in death. Okay, it could result in circulatory collapse and death, and it could even be fatal. So systemic anaphylaxis is a much more serious type of condition, and it usually occurs in response to injected antigens. So like, for instance, a bee sting or an insect sting causes between 50 to 60 deaths a year. And that is due to when you have the antigen causing the mast cells to release their mediators like histamine, which causes blood vessels to dilate and blood pressure to drop. That can be fatal, and at that point you really need epinephrine to constrict the blood vessels to prevent that from happening. Okay, so this is another scanning electron micrograph of pollen grains, and also of a house mite. All right, and so these would be antigens that would cause a localized reaction. Okay, so inhaled pollen, right, definitely could cause hay fever, or fungal spores, dander, something like that. So this would be in the upper respiratory tract. The symptoms would be itchy eyes, congestion, sneezing. So the mast cells of your mucous membranes of the upper respiratory tract would be releasing histamine. And that's why antihistamine, okay, would help in this situation. Would help you with your hay fever type symptoms. Asthma actually affects the lower respiratory tract, and it can be caused by this type of reaction as well, due to contraction of the smooth muscle. Okay, so the shortness of breath that you would have with asthma would be due to the contraction of smooth muscle. There are also a lot of people talk about food allergies, but most of the time they're really talking about food intolerances, and these are not allergies at all. So this isn't a true food allergy. There are true food allergies, and those usually result in hives. So eggs, peanuts, milk, soy, wheat, peas, these are all true food allergies, and they can cause systemic anaphylaxis. Determining whether you have sensitivity to allergens is done by this type of testing. Okay, a skin test to identify allergens, and what they do is they inoculate a small amount of a suspected antigen, okay, or allergen just below the skin. And if you produce, if you get like a little bit of swelling and redness and itching at that site of injection, it's called a wheal, WHEAL, then that's how you would identify the allergen. Okay, so the allergen is binding to IgE. Okay, IgE antibodies, and that is what is eliciting this damaging immune response. So for desensitization, okay, you've heard of that, right? And it does work. It does work really well. What you do is you add tiny amounts of antigen in order to elicit an IgG response. Okay, so this is the kind of response that we talked about in chapter 17, right? The protective response. So then you increase the dosage of the antigen, you do it sequentially, and as you are increasing the dosage, you would be producing IgG instead of IgE. Okay, and so now when you come into contact with the allergen, you would have neutralizing antibodies that could bind to that allergen and eliminate it, instead of the allergen binding to the IgE receptors and causing an immune response. Okay. So the type 2 reactions are the cytotoxic reactions, and these reactions would occur between 5 to 12 hours after exposure. So these reactions involve IgG and IgM antibodies and complement. All right. So we talked about that right in chapter 16. So complement would induce lysis of a cell, okay, and that would cause damage. The most common type of these type 2 cytotoxic reactions would be transfusion reactions. Okay, so this is looking at transfusion, how the transfusion reactions would work. So this is showing the ABO blood group system. So A and B refer to carbohydrate antigen on the surface of your red blood cells. So if you are blood type A, you have A antigen on the surface of your red blood cells. If you are blood type B, you have B antigen on the surface of your red blood cells. If you are blood type AB, you have both A and B antigens on the surface of your red blood cells. And if you are type O, you have neither A or B on the surface of your red blood cells. So we have, we can't have antibody against self. So like, for example, if you're blood type A and you have A antigen on the surface of your red blood cells, you wouldn't have anti-A antibodies, but you would have anti-B antibodies because that is not self, right? If you're blood type O, you don't have A or B antigens, so you could have anti-A antibodies and anti-B antibodies. For the AB blood group that has both A and B carbohydrate on the surface of their antigen, on the surface of their red blood cells, they would have neither anti-A or anti-B antibodies. O, you can see, is the universal donor. Okay, so everybody can take blood type O because it doesn't have any antigen. So the anti-B antibodies in blood type A are not going to attack anything on the O blood. All right, the anti-A antibodies in blood group B blood is not going to attack the O. All right, and then since you don't have any anti-A or B antibodies in blood type AB, okay, that's not going to attack the O red blood cells either. Okay, and while we're on blood group AB, since they don't have any anti-A or anti-B antibodies, they can receive blood from all of the different groups. Okay, so they are the universal acceptor of blood. Okay, so blood type B can only accept blood type B or O, and blood type A can only accept blood type A or O. Okay, and let's say that somebody with blood type A gets B blood. All right, this is where you would have the transfusion reaction. Blood type A has anti-B antibodies, so those anti-B antibodies would bind to the B blood, okay, that has B expressed on the surface of the red blood cells, and it would induce complement lysis of the red blood cells. Okay, so this would be a transfusion reaction that would be a problem. Okay, it would be a problem because the body would attack the red blood cells if they weren't the correct blood type. Okay, hemolytic disease of the newborn is also a type 2 cytotoxic reaction. This has to do with the Rh blood group system. So this is another surface antigen that is on the surface of the red blood cells. We have this in common with the rhesus monkey. Okay, so that's where the Rh is coming from, rhesus. So this is the Rh factor. 85% of people are Rh positive and 15% are Rh negative. Okay, so Rh positive means that you have the antigen. Rh negative means that you do not have the antigen. If you are Rh negative, you do not have anti-Rh antibodies. Okay, but you would develop them upon exposure to the Rh antigen. Okay, so in this example, if an Rh minus woman and an Rh plus man have a child, the Rh minus woman would now be exposed. Okay, well, not yet, not until the birth of the child, right? But the Rh minus woman would not have any anti-Rh antibodies, but upon birth of her child, she would be exposed to the Rh antigen and she would develop anti-Rh antibodies. So now, okay, if she has another child and it's Rh plus, her antibodies would attack the red blood cells of that child and lyse them. So this is not a problem while the mother is pregnant. Maternal circulation can remove the toxic byproducts of the destroyed red blood cells, but after birth, the newborn would be jaundiced and anemic. And so this is why, it's referred to as hemolytic disease of the newborn. This can actually be prevented. Okay, here's the diagram right here, right? Okay, so the Rh minus woman and the Rh positive man have this child, which is Rh positive. Upon birth, okay, the mother would be exposed. Okay, this is the sensitization reaction, right? And she would produce these anti-Rh antibodies. And so now, okay, when she has a second child that is Rh positive, her antibodies would be attacking the red blood cells of that child and causing fetal red blood cell damage. There's an easy way to prevent this, and that is by passive immunization. So when the Rh minus mother gives birth to her Rh positive infant, she could be given a passive injection of anti-Rh antibodies, all right, which would combine with the antigen, okay, the Rh positive red blood cells of the fetus, okay, or the newborn, and that would prevent her from being sensitized. Okay, this is another type 2 reaction, drug-induced cytotoxic reactions. So here, the blood platelets, okay, which are thrombocytes, are destroyed, all right, by a drug-induced cytotoxic reaction. Okay, so the antibody would induce complement lysis of the platelet, okay, or the thrombocyte. So drug molecules can act like this. They can be haptens, okay, so they're not antigenic themselves, but when they bind to something larger, right, they can become antigenic, and then the hapten antibody, okay, now it can bind to the hapten, okay, in the context of this of it binding to this platelet, okay, And so the antibody would bind and it would induce complement lysis. So the platelets are involved in blood clotting, and without them, hemorrhaging would occur under the skin, and that is referred to as a purpura. So this would be a drug-induced thrombocytopenic purpura. Okay. And then the next type of hypersensitivity reaction would be the type 3 immune complex reactions. These occur 3 to 8 hours after exposure. They involve circulating antigen, soluble circulating antigen. So when antibodies bind to this antigen, those immune complexes that can form, right, they would get lodged in basement membranes and cause inflammation. Okay, and they can also induce complement. Okay, they can activate complement. Okay, so an excess of antibody, okay, remember when we talked about that in chapter, what was that, 18, where we were talking about the immunological diagnostics? If you have an excess of antibody, so you have lots and lots of antibody, not that much antigen, okay, you're not really going to create the immune complexes, right? So when you have a lot of antibody and not much antigen, that actually leads to complement fixating complexes. On the other hand, if you have a huge excess of antigen, the immune complexes that can form are going to be small, right? It's when you have that perfect amount of antigen and antibody that it leads to those large immune complexes. Okay, so in this situation, the immune complexes would be small, and they would escape phagocytosis, and they wouldn't cause inflammation. They would circulate in the blood, and then they would pass through the endothelial cells of blood vessels and become trapped. Okay, so now when they're trapped, okay, in the basement membrane of the blood vessel, they can activate complement and induce a inflammatory response. Okay, so here you can see in the figure that you've got neutrophils coming and causing damage basically to the basement membrane of the blood vessel. All right, and the fourth type of hypersensitivity reaction would be the cell-mediated reactions. The cell-mediated reactions take between 24 to 48 hours, and the reason why is because that amount of time is required for T cells and macrophages to actually migrate to the foreign antigen. So this is a cell-mediated immune response that is caused by T cells. Okay, and some of these you might even recognize. So the sensitization would occur when the foreign antigen is phagocytosed by macrophages and presented to T cells. And then T cells with complementary receptors would contact the antigen and proliferate and differentiate into memory cells. Re-exposure, okay, so this would be the damaging secondary response. The memory T cells would then activate T cells to release cytokines, which would contribute to inflammation and attract more phagocytes and initiate the tissue damage. Okay, so the next slide here. I said, so some of these reactions you might recognize. Actually, the tuberculin skin test, which I don't think they do that often anymore, that is a delayed hypersensitivity reaction. That is a memory T cell response. When you get the little blister, okay, that would indicate that you had had some type of exposure to Mycobacterium tuberculosis. This figure that we're looking at right here is actually showing allergic contact dermatitis for poison ivy. Okay, poison ivy. And it's showing how that allergic contact dermatitis develops. So the poison ivy has these catechol, which are oils, and when the oils interact with your skin proteins, now they become antigenic and they can provoke an immune response. Okay, so the first response would be, not that bad. Okay, I think some people do react the first time they come in contact with poison oak. But the second response would be much worse. All right, so I heard somebody say like, "Oh, now that I've had poison oak, I'll never get it again." Like I'm protected. No, 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 no. So this is the hypersensitivity reaction where the second time you get it, it's actually a lot worse. Another picture here. This is contact dermatitis from latex gloves. And so it's the same type of thing where the latex can complex with your skin proteins and cause an immune response and a hypersensitivity reaction. Nowadays, we mostly suggest that people use nitrile gloves and not latex. We can just go ahead and skip this about delayed rash. It's pretty interesting though if you wanted to read on it in your book, but I'll skip it for now. I just wanted to also talk about autoimmune diseases. So these are, of course, reactions that are also damaging, right? So the autoimmune diseases occur when your immune system recognizes self-antigen. Normally, if during development of the B cells and the T cells, they recognized self-antigen, you would go through a process referred to as clonal deletion to ensure that you wouldn't have these autoimmune disorders. Okay, so to ensure that you would have self-tolerance. But when self-tolerance is lost, you can have autoimmunity, and this would cause damage to your own organs. It turns out that 75% of autoimmune diseases affect women, and that women have more autoantibody producing B cells. And so loss of self-tolerance would be loss of the ability of the immune system to discriminate between self and non-self. And when you have that loss of ability to discriminate between self and non-self, then that can result in your immune system attacking your own self antigens, and that is what would be referred to as an autoimmune disorder. So antibodies or sensitized T cells could attack the person's own tissue. Autoimmune reactions or autoimmune diseases can be cytotoxic, they can be immune complex, or they could be cell mediated. I'm going to just talk about a couple different types of autoimmune diseases. So we'll talk about the cytotoxic and also the cell mediated, so Graves' disease and multiple sclerosis. Immune complex reactions, that would be like lupus. I'm going to just kind of pass over that one, but we'll talk in a little bit more detail about cytotoxic reactions with Graves' disease and cell-mediated reactions with multiple sclerosis. So in Graves' disease, the thyroid gland is stimulated to produce large amounts of thyroid hormone. And so this really revs up your metabolism. And when the thyroid is producing all of this excess hormone, and it leads to, well, I think one of the most distinguishing signs of Graves' disease is bulgy eyes. So a lot of people who have Graves' disease have like very bulgy eyes. Their heart can be pounding, they can be trembling, sweating. They can even have a goiter from the thyroid being so overstimulated. So normally, the pituitary in the brain would release TSH, which is thyroid stimulating hormone. But due to a malfunction in your immune system, you produce antibodies that mimic TSH. So you have these antibodies which are stimulating the thyroid to produce the hormone, and that leads to Graves' disease. So for the cell-mediated autoimmune reaction, so this would be mediated by T cells, that is multiple sclerosis that we'll talk about. Again, women are twice as likely as men to get multiple sclerosis, and it usually occurs more often in white people and also in young adults. So in this particular disease, T cells and macrophages, okay, it's cell mediated, are going to attack the myelin sheath of nerves. And so the myelin sheath of your nerves is responsible for expediting the synapse, or not the synapse, but the what is that called? The transmission, right, of the signal of your nerve. And so when that when the myelin sheath of your nerves is degraded, okay, by these T cells and macrophages that are attacking it, you eventually have a form of paralysis, and the symptoms can range from weakness and fatigue to this eventual paralysis that would occur over many years. There is some evidence for genetic susceptibility, and even though the etiology for multiple sclerosis is unknown, they suspect that there could be an infectious agent and the Epstein-Barr virus turns out to be commonly associated with multiple sclerosis. Okay, so I believe that is the last slide, and I will get this posted as soon as possible.